Hi, good morning. Myself, Dr. S. Prakash, currently working as an associate professor, and I am also a Fulbright Nehru postdoctoral fellow at Center for Climate Change Studies, Satyabama Institute of Science and Technology. And today we will be talking about the microplastics and its sources, its impacts, and then how we can able to mitigate over the time. I will now share my screen. I hope it's visible. So today we'll be dealing about the marine microplastics, especially on the sources, impacts, and the methods for mitigation. So what is a microplastics? So usually it could be of any general plastics, that would be of plastic bottles or polythene bags or whatever the material that we have been using as a plastic. So microplastics are mainly differentiated in terms of sizes. Okay. So whatever the plastics we are using are called as a macroplastic because it has more than 5 mm in size. Okay. So the microplastics will range from, I'll just take a laser pointer here. The microplastics will usually range from 0.1 micron to 0.5 mm in sizes. And there are also nanoplastics. So we will see how these microplastics are getting fragmented into a microplastic, mesoplastic, nanoplastic, and rest of the all. So once these microplastics enter into the ocean, and there is a possibility that it could have been aggregated into a form of a marine snow, into the feces of fishes or other animals, and then it could also attach to other bacteria and fungi and then directly enter into the sediment, what we call it as a plastic export. So microplastics are nothing but the small fragments which is less than 5 mm in size, and it could also have the possibility to pollute our oceans and also harming the marine life. So we will see in detail that what are all the threats it has been causing to the marine environment as well as the marine organisms. So there are variety of sources that has been, the microplastics have been generated from. It's called from the cosmetics, from the textiles, and then from the breakdown of other larger plastic items. So there are several sources of microplastics that has been formulated or that have been standardized. That one is the primary sources, where we have been mainly using such as microbeads in the personal care. So that is what the experts or the environmentalists used to say, that do not use microbeads, formulated shampoos, soaps, or any hair care oils and all those stuff, because all these microbeads are not dissolvable, and all these microbeads end up in the rivers or in the ocean in the form of a microplastics. So there are also fibers that have been coming out of synthetic textiles, and there are also plastic pellets that have been generated from the industrial manufacturing. So there is a secondary source, which is mainly the fragmentation of larger plastic items like bottles, bags, which has been fragmented due to weathering and wave action. And in terms of fragmentation of microplastics, so there are several factors that have been combinedly involving in degrading these plastic items. So last is the land-based resources, where whatever the plastics that have been generated or in the environment are getting transported to the waterways through littering and end up in the rivers or oceans. So one of the figure which is showing here is the Antarctic seal, which is getting entangled with the help of the fishing nets. And then second one is from the Chennai coast, where in the intertidal pools, you can see the plastic bottles that have been got trapped inside the tidal pools of a rocky shore of the Chennai beach. So next is there are different pathways that have been established where the microplastics are getting into the marine environment. So one is the terrestrial sources, as we have seen before, whether it could be of rivers, runoff, wastewater that has been carrying these microplastics from land into the oceans. And then second one is the transportation through ocean currents and tides that could distribute the microplastics throughout the marine environment. So, for example, if any person is drinking a Coke or any other item, and then they just throw into Malaysia or Singapore or any other Pacific islands, and there is a possibility that the waves and the tides have the capability to transport these microplastics into different parts of the world, so that it could end up even in India, especially in Chennai or Calcutta or in Mumbai or any other places. And the last pathway is through the ingestion of microplastics, where the possibility of the animals, especially fishes or other even lower invertebrates, have the possibility to engulf or get trapped in these microplastics. So what will happen over the process of a food chain? So even a smaller fishes can be taken or engulfed by the fishes in the higher tropical level. So all these will end up in the predator, and those predatory organisms such as sharks or larger fishes have been again engulfed by a larger predator called the humans. Okay. So what will happen? So the process of bioaccumulation takes place in the humans, and which will lead to the toxicity in all the organs. So these are some of the pathways that the possibility of microplastics that would end up into the marine environment. And microplastic is not just a single plastic or single material. So it composed of variety of materials such as polystyrene, polyformaldehyde, and there is a polyvinyl chloride, polyesters, polypropylenes, polyamides, and polyethylene. And unfortunately, only these materials are not causing toxicity in the fishes or in humans, but there are also several heavy metals and other compounds or other toxic compounds that has been associated with these microplastics. So all these microplastics as well as the associated compounds are getting entrapped or observed by these plants and animals and end up in the humans by causing oxidative stress or inflammation, and especially affecting the organs such as kidney, gut, as well as the liver. Okay, so you could see how much the impact of microplastics are creating in the environment. So as we were discussing before, there are factors that has been influencing the degradation as well as the fragmentation of microplastics. So there are physical factors, there are chemical factors, and then there are biological factors that has been responsible in degrading these microplastics. Of course, it is not totally degrading, but it's basically fragmenting the macroplastic, which is having more than 2.5 centimeter, that will be converted into mesoplastics, whether it could be of a physical action such as UV radiation from sun or photooxidation, or it could be through wave action, as we were discussing that the ocean waves and tides have the capability to transport these microplastics. Okay, and there is also a thermo-oxidative degradation that has been happening in fragmenting these macroplastics into mesoplastic as well as the microplastics. So these microplastics will again get into fragmented into a nanoplastic, and there is also a possibility that these nanoplastic have been getting converted into oligomers and then monomers. So once these microplastics are getting trapped into these smaller animals, there is a possibility that it could easily enter into the food chain. So the physical and the chemical, there is a salinity fluctuations, especially the compounds such as sodium, sulfur dioxide, magnesium, and chlorine can also helpful in fragmenting these macroplastics into a microplastics. And there is also a biological process. There are some bacteria, fungi, and algae that could easily helpful in degrading these, fragmenting these microplastics by adhering on the surface of this. And then there is a possibility this biofilm formation could be helpful in fragmenting the macroplastics into a microplastics. So this will cause potential impacts. So first one we have already seen into the ingestion. I will explain this in detail in the next slide. And there is a possibility that the habitat fragmentation can happen. I'm sorry, habitat degradation can happen. So what will result is, what will lead to is, these microplastics will have the capability to block the breathing holes of the mangroves, and it will also get trapped by the coral reefs or by the seaweeds or the seagrass ecosystems. So once these microplastics or these nanoplastics or oligomers and monomers get trapped into the breathing holes of the mangrove plants, then there is a possibility that the mangrove cannot able to breathe. So the marine biologist or anyone know about the mangroves can able to imagine that the mangrove plants are having a specialized breathing roots. Okay, so if these microplastics are getting trapped into those breathing roots, then there is a possibility that it cannot able to breathe properly, and it will result in the death of a plant, mangrove plant. Okay, so trophic transfer, as I was mentioning about that, once these microplastics are engulfed by a smaller animal, and then there is a possibility that it could lead to the, it could enter the food chain and then end up in the humans. And there is a toxicity, as I was mentioning, that only the microplastics are not toxic. Only the microplastics are also toxic, but there are associated heavy metals and other toxic compounds that has been highly that is getting leached into the water, which will have acting as an endocrine disruptor, or it will also failure the reproductive systems of the marine life. So you can see some of the pictures where the seagrass, seahorses usually resides in the seagrass environment, but you can see the cotton bud have been folded by the seahorse. And there is a possibility that the plastic papers or polythene bags have been considered as a food for by the sea turtles. Why? Because the food turtles usually takes 30 to 60% of their primary diet as jellyfishes. Okay, once these polythene bags are in the environment, then the turtle would mistake that the jellyfishes as the polythene bag. So it would directly end up in eating the polythene bags. And here you can also see that a marine bird or a seagull is holding a Lays chips packet in its beak. Okay, so this will see that how much the humans are impacting or littering the environment. So this is one of the excellent slide that has been depicting the combined effect of microplastic and the pollutant towards the marine organism. For example, there are heavy metals, there are hydrophilic compounds or antibiotics, and there are hydrophobic compounds such as PAH, polyaromatic hydrocarbon, or PCBs and PBDs. So if these compounds that has been released into the environment, and it has the capability to get trapped with the microplastics. Once these contaminated microplastics enter into the fish, then it will affect the brains, it will affect the muscles, kidneys, swim bladders, ovary, stomach and intestine, heart, liver, gills. Of course, almost all the parts of the fish are getting infected. So what will happen? These microplastics have the capability to get entrapped in the gills, as I was mentioning for the mangrove plants. Okay, so these fishes usually breathe through the gills, right? So once these gills are getting trapped by these microplastics, then the fishes cannot able to breathe properly, which will end up in the death of the fish. Okay, so if these microplastics are getting accumulated, then we call it the process called bioaccumulation. If this fish has been caught by a fisherman and then it's sold to consumer, then end of the day we will also take so much of microplastics that are getting trapped in the human body. So there are certain innovative mitigation measures have been coined. One is through the recycling and the waste management, because we have to improve the waste collection, as so many governments have ordered to segregate the waste such as biological waste, hazardous waste, or the non-degradable waste, right? So those things need to be more efficient in order to recycle these plastics, and so that we could reduce the pressure of these microplastics that are entering into the ocean or the rivers. And product design and substitution, we could always come out with alternative materials. I think recently there are bioplastics that has been produced from the waste of seaweeds and then from the waste of sugarcane, because India is the largest producer of sugarcane, right? So in Delhi, I think there is a startup company who have been producing these bioplastic material or the utensils using these molasses or the bagases from the sugarcane. Okay, so we can also redesign several alternative products so that we can eliminate the use of plastics in our day-to-day life. And there is also a cleanup and removal technology. We can develop innovative technologies so that we can reduce the use of microplastics in the environment. So next is the transdisciplinary approach. So what we can do is we can recognize and act in order to create transparency or create awareness about the microplastics. So we can incentivize or design policies that has been helpful in order to reduce the microplastics usage in the environment or in the industry or in the day-to-day life of a common public. We can also transform socio-economic pathways, that we have to define the plastic chemistry to the government so that we can know whether we are using harmful chemicals in our production. Last but not least, we will try to conclude and call for action regarding the microplastics. So first is the urgent action that is needed in order to address these growing crises. As I was mentioning before, we could able to create awareness among the students, among the general public through various outreach programs, and the individual responsibility is more important, such as self-discipline. Even if we are going to supermarkets, even if we are going to buy some veggies or to buy some groceries, or even to restaurants to bring some food, what we can do is we can carry our own utensils and then our own bag. Okay, so in this, uh, uh, a small step will definitely increase or helpful in reducing the plastic pollution. And collective advantage or collective solutions are much needed if we collaborate with governments or R&D institutions or any essential industrial partners who can be helpful in order to reduce these plastic pollution and then produce a mitigating solutions for reducing the microplastic pollution. Okay, so with this, I will end up my lecture, and then whoever have any comments regarding microplastic or whoever have any solutions in order to reduce the microplastic pollution in the marine environment or in the land, so you are most welcome to comment in the video. Okay, so I thank you all for listening to this, and then our collective actions are much needed in order to protect our environment for the next generation. Thank you.